Got you.
Okay, so hi all. Thank you for coming to Code Resolve's Python Pong workshop today. Hopefully everybody's here because it's time. So we're going to go ahead and start the workshop. And the agenda for today is I'm going to introduce to you the leads of this workshop, what Pong is, how we're going to use Turtle to implement it, and then we're going to dive into the code. So first, my name is Lily. I am the secretary of Code Resolve, and you can often find me in the library doing work. And although I may not look friendly when I'm working, I'm very open to meeting new people and interacting with members of our club. So it's nice to meet all of you and be one of the leads for this workshop today. Martin, you want to introduce yourself?
Yeah. Hey, I'm Martin. I am the website maintainer. I love Python. That's why I'm part of this workshop. There's nothing else to my personality. So Chris, you can go on ahead.
Yeah, I'm Chris. I actually don't know anything about Python, so interacting with the workshop and learning about it, it's like pretty big to me, and I'm glad to be here.
All right. Thank you, Chris and Martin, or the Coldplay lead singers. Anyways, as we mentioned before, we're going to build a simple Pong game today. And if you don't know what Pong is, it is a classic arcade game that involves two players. One controls the left paddle, or like that rectangle you see on the screen, and the other player controls the right paddle on the other side. And they just hit the ball back and forth. And if the ball crosses over onto the sides, that player loses and the other wins a point. And it's literally just the actual sport ping pong, but in 2D form. So you can kind of see how the logic lies in the ball's movements. Like the ball is able to bounce on the top and bottom boundaries of the screen, but like if it bounces to the left or to the right, that's when we calculate the points and we like restart the game or loop the game over again. And that's the basis of our code today. And the approach we're going to take to build out the game is with the Turtle library. Typically, games are made with the Pygame library, which includes like graphics and music you can use for like Python games, but we chose Turtle because it's a little more intuitive for beginner Python programmers, and it's already built into Python. Pygame would just require some time to install all the packages, which we don't have time for today. So yeah, we're just sticking with Turtle. And Turtle helps us create various images and shapes using the concept of like a drawing pen like we do in real life, but like they don't call it a pen, they call it a turtle. And we just control it by giving it a bunch of commands and customizations. And people like making spirographs out of it. It's very useful for math, and people like literally make any image out of it. So like it's very ideal if you enjoy making visuals and you want to learn how to systematically create images. So now we're going to just like jump into Replit. I'm assuming you already have a Replit account because we strongly encourage that in the RSVP form. And the reason why like the leads are using Replit today is because it's a good collaborative tool for multiple programmers to use at the same time. And in our case, to show you all like how it works, we're using it. But honestly, you can make this game on any IDE. It doesn't have to be Replit because like Turtle is built in any Python IDE, but like the syntax we use for today in Replit, I'm going to like set a disclaimer is that like Replit commands for Turtle is going to be different from like how you typically use it in like your typical IDE. So just keep that in mind, and just remember that when we talk about like imports and certain methods that we use today. So I'm going to exit out of the presentation and just hop onto Replit. So this is our homepage for Replit. We can create a new project on the top right corner on this button with the plus sign. So I'm going to create a new thing. It's going to be in Python, specifically with the Turtle library. I'm going to select that and I'm just going to call it Pongers. I don't know. It's loading. Let me just quickly invite the other leads. Hold on. Okay, so on the very left, we have the file directory. In the middle, we have the actual code we're going to make, and then on the right is our output to see like how we're doing in terms of like how the code works. So to start, we're given a kind of default template. I'm going to walk you through what this all is. Lines 1 to 7 is just comments explaining what Turtle is. And like I said before, Python with Turtle lets you make graphics easily in Python. And just skipping through all those comments onto line 9, this is where we import the library, import Turtle. And again, it's going to look different on your typical IDE, but this is how Replit imports the library. Line 11 is when we use one of the functions or like the methods in the library and kind of create a new Turtle object. And it uses .turtle with parentheses to make it. And we're going to call it the variable t, but it could be any name you want. And on line 13 is a for loop where we actually use the turtle. So basically what this for loop is doing is it's going to iterate through this string array of different colors, red, green, yellow, blue. And for each one or each C in there, it's going to, on line 14, set the color of the turtle. And if you roll over the function, it's going to give you like a synopsis of what the method does. So in this case, color, it returns or set the pen color or fill color of the turtle or the pen we're using. So it's going to adopt like the color based on the iteration we're on. So it's going to take red on the first iteration, take green on the second, yellow on the third, and blue on the very last one. Let me keep going. On line 15 is when we actually kind of move our pen or turtle around. It's going to call forward 75. What this means is it's going to go forward in one direction 75 units. And this kind of turtle uses like a graph with like an x-axis and the y-axis to kind of control its pen and like the position the turtle is in. So in this case, we would kind of create that turtle object in the very center of our screen, 0, 0. And let me show you what it means. So I'm going to comment this out. Just hold on. Oh my God, it's a little slow today, but it's fine. So if we make the color black, for example, and then we move it forward 75 units, it's going to run like this. So it went, I guess, forward 75 units in its own perspective. So when I first worked with Turtle, I thought forward meant like an upward motion, like it would go up this way, but it goes to the right or like our right because it's facing that way because of the arrowhead here, like the tip is like the orientation of where it would go. So if you want to move it different directions, you can. So I'm gonna just move this back here and uncomment some stuff. And on line 16, t.left 90, that means we're going to orient the position of the turtle like 90 degrees. So whatever number you put in here represents the degrees, like 180 degrees, 360 degrees, like any number that's less than 360 is going to change it, like its orientation. So right now the arrowhead is facing like towards our right, but once we do this left 90 degrees, it's going to just like rotate itself to the left 90 degrees. So to see that, I'll show you. So right now the arrowhead is pointing that way. It should turn like upwards, like R upwards. Yeah, so as you can see, the arrowhead changes a bit because the way I like to like think about it is like when you use Google Maps, like you see a blip on the screen and that represents you and your position, but also it takes into account like where your phone is pointed. So if you kind of like move your phone around like your I guess direction also changes. So that's the same concept for this turtle or like this arrow here. So you don't even have to move it just to the left. You can also move it to the right by 90 degrees and it'll point the arrowhead like downwards. That same concept. Yeah, so it's downwards here. It doesn't have to be 90. It could be like 180. So it'll go like towards where the line started. Yeah, so that's how you kind of just like move it around and just in general make it work. So let me think. I'm going to uncomment this. So when we run this for loop, it's going to, it should make like a square of different colors because it's constantly just going forward and then orienting itself to the left. So it's going to look like this. Oops. Hold on. It should be 90 degrees. Just like that. So that's a very simple for loop that Replit gives us. But if we want to further customize it, we can. So let me comment this out. So we have our T or our turtle here. We can set the color to whatever we want. It could be red, it could be yellow, it could be green, but I'm gonna go with pink because it's cute. And in order to see that, we would have to like move the pen forward just to like test it out. So I'm just gonna grab line 15 and just paste it there. I'm gonna set it to 100. So it should go a little longer than what we're seeing on the screen. Yeah, so our arrow is now pink. It went forward 100 units. But I don't really like how thin the line is. I can't really see it. So you can always play around with the thickness of the line as well. And you can do that with the method pen size. So by default, pen size is 1, which is like the thinnest option. But if you like just increment it bit by bit, the line gets thicker. Okay, yeah, so it got thicker. If you turn it up to 10, it's even more thick. And I think that's how the person that made the Among Us picture, they probably set the thickness to 10 or something. You can also change the shape of the arrowhead. So it's not just like an arrow, it could be like a circle. Yeah, there's a circle, it could be a triangle, it could be like a square, but there's also the turtle that like, I like. I'm gonna keep it that way. Look at that, okay. Yeah, so those are just a few ways to customize like the pen you use. There's more like things to do based on the graph system that Turtle uses, and we're also going to utilize that in our code for Pong today. So to get into that, let me see. Okay, so I'm gonna comment this out for now. So when we first create our turtle, like I said before, it should be in position 0, 0 because it's in the center of the screen. And we can see that when we use a function called xcore, which basically returns the x coordinate of the turtle at that certain position. So I'm going to just print this out so we can see along with its corresponding like y coordinate method. So both of these should return a 0 because we just initialized the turtle at line 11. Exactly. So that's because we haven't moved it. We just created it. However, if we do move it like 100 units, let's say, it should say like the x coordinate is going to be 100 and then the y coordinate is going to be 0. Yeah, so it's just going to constantly change depending on how you move it around. And let's say we also want to move it to like coordinate 100, 100, let's say. Oops. The x coordinate is 100, the y coordinate is 100. It's at that specific spot. So that's how you can kind of just tell the positioning of the turtle at that instance. However, if you want to like move it, like reset its position without like making that line, there's a method called pen up, which is like in real life when you have a pen and you're drawing and then you pick it up and you move it like elsewhere on the page, it's not going to create a line or like leave any traces of itself there. So that's like the same concept here. So if we're already at like coordinate 100 and then we call pen up, it's just going to pick up the turtle and just relocate it somewhere else. So you can kind of see that when we do like a repositioning of it. So we're going to reposition it with a function called setX. And let's say I want to just move it back to the center here. So it's no longer going to be at position 100, 100. It's going to be at position 0, 0. That's what I want. So I'm just going to grab the current x coordinate that it's on. I'm just going to minus it by 100 because it's going to give us the, like, it's going to reset its position. So wait, okay, I'm not going to print that out, my fault. I'm going to print that after. Repeat that for the y coordinate. And I'm going to print T. So just watch the screen and then it's just going to reset itself without drawing that line. And again, this is going to come in handy when we kind of create our like ball object in the Pong game. So the Pong game will utilize a lot of the graph system that Turtle uses and like just move around like its x coordinate and y coordinate and then like reset it, and also use pen up to make sure the game looks clean. So that's the end of our little mini turtle tutorial. I'm going to pass it to Chris to actually begin the coding of the Pong game. Chris, you good?
Oh, yeah. Let me just share screens. Tell me if you can see it.
Yeah, I see it.
All right, nice. So I'm gonna get rid of yours, or do you want me to just make it into a comment?
You can get rid of it, it's fine.
All right. I'll just Command C. All right, so now that Lily has shown you the whatchamacallit, the basics commands for Turtle and Python, we're gonna actually like invent the game. We're gonna actually create the game right now using the commands that she taught you and a few other commands that I'm gonna teach you along the way. Hopefully you have Replit as well, as this shouldn't be too hard. Like when I started, I was completely new to Python and Turtle. So I was like, I don't know how I'm gonna do this, but Turtle really makes it like super easy. So it shouldn't be too complicated. I'll put comments along the way so you can understand, and I'll annotate as well. So I'll start right now. So we first import the Turtle. That's like how we're gonna begin any program that includes Python and Turtle. And we're gonna start with the game preferences. So we're gonna include the players that are gonna play. There's gonna be 2 players for this game. So we're gonna put player A and player B, but I'll put player A score because we wanna tell the game. This is a game that relies on a point system. So we're gonna do player A and player B score, and their initial score is gonna be 0. So this is gonna be their initial score. Now that we have the both players, we're gonna actually like make the window itself. So I'm gonna start with window. That's green. This is the Excel. Okay, so we're telling the game that we're gonna start making the preferences for the game. So I'm gonna start making the title. So window title. Gonna make it 4 pongers. Then we're gonna do the window background color. Give it a nice pink color. What else? We're gonna include. We're actually gonna set up the width and the length of the game. So I'm gonna do window setup width. I'll make it like 800. It's best to keep it not too big since Replay isn't like such a big program. It doesn't have much of a space here. And then the height, we want to make it 600. And we want the game to run smoothly, so we're going to include window tracer. You just want to keep this as 0. It just makes the game run smoothly. So that's like the main template of the game. So we're going to say template of game.
By the way, on line 17, it should say .bg color, not bg.
Yeah, I was just seeing that right now.
Yep.
Thanks. All right, so that's the template. Now we're actually gonna make the paddles. So I'm gonna include. We're gonna start off with the left paddle. So left paddle here. Copy this just to make it easier. Turtle. Okay, so we're telling the game we're gonna include the commands for the left paddle. So I'm gonna put the speed of the paddle. The reason I'm putting 0 is because we don't want the paddle to move like once we start the program, but we're telling the game that it's gonna have some kind of movement later on, which I'll explain once I continue coding. I'll tell you what kind of code I'll include. So we're gonna keep the speed at 0 first. The left paddle, we're gonna write the shape of it, the shape. Could make it a rectangle, put a square out. Doesn't really matter. The left paddle, I'm gonna include the color for the paddle as well. Can make it a black color just so it could stand out. Then we want to include the shape size. So this is the width and the length. The width is going to be 5. I'll make the stretch length. Let's make it 1. And then this is where we're actually gonna like locate the paddle in the game. So left underscore paddle, pen up. If like Lily mentioned before, the pen up is so the game will draw a random line throughout whenever you run the program. It'll just locate the paddles without drawing anything. So you'll see once I do it, left underscore paddle. Go to, this is the coordinates. I'm gonna put -350, comma 0. All right, so I'm gonna illustrate this. So let's say this is like the game right now. Ignore like my bad drawing skills. All right, so we have, this is the center of the game, and the left paddle, I put go to -350, comma 0. So the x-axis will go to -350, so that'll be towards the left, but the y-axis stays the same, so it'll be right around here, parallel to the center. So this is where the left paddle would be. And the reason I put pen up is because if I didn't put pen up, then it will draw a random line from here to here, which is not what we want. So for now, we have, this is how our screen would look like if you were to run the program. And we would do the same exact thing now for the right paddle. So hashtag right paddle. That, what's it called? The number here is just a comment. It's not actually a command. So for the right paddle, we'll do the exact same thing we did here. For the right paddle. We're creating the right paddle. We're going to do turtle. None. Over here, we're going to do the same exact thing. The speed will be 0. Then after speed, we have the shape. The shape, make it square. Then we have the color as well. Color, make it black. We have the speed, shape, color, like we did here. Now we want the shape size. Just gonna copy and paste, same exact shape size. Then we have the left paddle pen up, because that means we're gonna locate it somewhere. And then, sorry, right paddle. And then this is the important part that actually changes. So we're gonna put right underscore paddle. Unlike the left paddle, where it's negative 350, comma 0, it's gonna be positive 350, comma 0. So if you were in like, for perspective, this is the origin right here. The y-axis stays at 0, so it'll go straight towards the right. Since 350 is positive x is towards the right. So the right paddle will be right over here. So these two will basically start opposite of each other. And we made the paddles. That's the paddles right now. And now we're gonna actually make the ball, which is like a very important part of the game. So I'm gonna start importing the ball. Creating the ball. So for the ball, we're gonna do ball equals turtle.turtle. On the game that we're gonna make the commands for a ball. And we're gonna include the speed. Speed 0. It's gonna have some kind of movement, but we're gonna include that later on. The ball shape. This one, if you really want to, you can make it any other shape, but make it a circle. You want the color for the ball. So ball color. Ball color, we'll make it white. Right, it's all right if it's white because it looks white here, but I made the background pink, so the ball is not gonna blend in with the background. Okay, so we have the color, the shape. Now we're actually gonna locate the ball, so we're gonna do pen up. And ball go to 0, 0. So the ball, which is the circle right in the middle. So it'll be right between the two paddles. And this is an important part. We're actually going to include the movement of the ball right here, the direction it'll move to. So we're going to do ball X direction and the ball Y direction. And we'll make the direction 0.3 here, 0.3. The reason why I put the X and Y direction is that so the ball won't move left and right, and it won't move up and down or left or right. Instead, it'll move diagonally as it's moving through the X and Y axis together. So since I put both of these axes, it'll only move towards northwest. So you see top right, top left, bottom right, or bottom up. It'll only move one of these 4 directions. It could be completely random, but it will never move straight to the left or straight up. So that's the direction of the ball movement. All right, now we're actually going to include the scoreboard. So we're going to create the pen for the scoreboard. Let's create pen for scoreboard. So this is what's going to tell the players that are playing the current score of each player. So we're going to start out with pen equals turtle.turtle pen.speed. We're going to keep it at 0. The color of the score, blue. I'll make it a blue color. We're going to locate the scoreboard, so we're going to put pen.pen up and pen on hide turtle. Then this is where we locate it, pen.go to. So the scoreboard is going to be on 0, 260. if you don't know where 0,260 is located, this is the origin, the x-axis is 0. 260, meaning it'll be straight above. So the scoreboard will be right around here. This will be the scoreboard. These are the paddles, and this is the ball. And then for the scoreboard, we're gonna tell it to write, pen.write. It's gonna say score. We're gonna align it at the center. And we can even put a font for it. So I'm gonna put font equals, make it a Arial font with size, make it size 24, normal. So this is telling us that it'll say score right over here, and it's located at the center and the top, and the font will be Arial 24 normal. Let me fix that. Should be good. So now we have the ball, the size of the game, the paddles, and the scoreboard. And now we're actually gonna implement the movement for both paddles. So here we're gonna start off left and right paddle movement. So now that we have all the shapes and sizes we need, we're gonna actually start the movement. So I'm gonna start off with the left paddle up movement. So I'm gonna put left paddle up. This is for the up movement for the left paddle. We'll go y equals left paddle y coordinate. So we select the y coordinate. So the y equals y plus 60. This means that the movement will go up 60 units. I'll explain that in a moment. Left paddle set. All right, so what this is telling us is for the left paddle, here we're choosing the left paddle, we're choosing the y coordinate, meaning it'll move up and down on the y coordinate. The y equals y plus 60 means it'll move up only 60 units. I chose, the reason I didn't make it like more than 60 units is because it'll go out of bounds and the paddle could just go up infinitely, which is what we don't want. And once it moves up 60 units, we put set y. So we set that as the maximum position. So basically this is like the maximum height it can go. And we actually do the same exact thing for the left paddle, but then now for the down movement. So left paddle down. There you go. For the left paddle, I believe it should be more or less the same. Y equals left paddle y coordinate. The only difference here is that we will y equals y minus 60. So it'll move down 60 units instead of up. That's the only difference between both. And left paddle not set y. I'm like making sure this is right. Yeah, so these two are basically the same. It's just that we're doing minus 60. So in this case, it'll move down 60 units, and that's the limit. And that's your left paddle up and down movement. Basically, we do the same exact thing for the right paddle. So I won't forget this. Fine. I'm gonna do left right paddle up like usual. Y equals right paddle. We're selecting right paddle. Y equals y plus 60. It'll go up 60 units. Right paddle. So why we set it that to the maximum height. And then you do the same exact thing for the right paddle. Now the right paddle down. So just to make things easier. Here we do y equals y minus 60, goes down that many units. right paddle Y. So here we have it. We have these two here. Sorry, these two here. We have the left paddle up and down movement, only a limit of 60 units, and we define it here. That's the maximum. And we do the same thing for the right paddle. Right paddle, we select it, we move it up 60 units, that's the maximum. Right paddle over here, oh, right paddle down, got that one wrong. Right paddle down, we do my minus 60, goes down 60 units, and this is the saying that's the limit. So left paddle up, down, right paddle up, down. So right paddle Y movement. Just to make it more clear. We have now we have both paddle movements. One here, this here, this here. So far we have the scoreboard, the game layout, and now we have the movement for the paddles and the ball. So we have the paddle, we have the movement for the paddles, but there's only one problem, like the game doesn't know when to move it. So this is where we include the keys where we press on. So we're gonna assign keys to the game. So whatever keys we press on will move the paddles. So I'm gonna assign keys to turtle. And the first command you want to put is window.listen. This tells turtle to listen for outputs. And well, this tells the turtle to listen for inputs and outputs the following commands. So I'm going to do window on key press. So when a specific key is pressed, the left paddle up on W. This here tells it that when on key press W, when someone clicks on W, the left paddle will actually move up to a maximum of 60 units. And it'll do this now. Let's do another one here. Window on key press. Should be the same thing. Left paddle. We want the down movement now that we already have the up. So if the up movement will be W, we'll make the down movement S. Most common games is like WASD. So we're doing WS in this case. And that'll be player one, basically, left paddle up and down. Now we're going to do player two. It's basically the same exact thing. Instead of left paddle, we're just going to see right paddle. That's the only difference. Right paddle up. And since we already used W and S, you can make the up down keys anything you want. In this case, I'll make it the arrow keys. So I'm going to say up. And for the right paddle down movement, right paddle down, I'm going to make it the down arrow key. In this case, down. And now we can actually control the paddles once we run the program. And we have this here. All right, so that's like basically the main format of the game. So now you've already created the objects like the ball, both paddles. You have the movement for the ball and the paddles, and you have the game size. But now Martin's going to actually talk about the collision between the ball and the walls and the paddles, which is like one of the most important parts, how objects interact with each other. So you want to take it from here, Martin?
Yeah, got you.
Yeah.
Thank you, Chris. Yeah. So yeah, if you've noticed so far, what we've really coded is we've only really coded like static like pictures on the screen, and we've also coded in how to move the paddles, but we haven't actually dealt with any of the other mechanics, like if the ball hits the paddle, if the ball hits the wall, keeping up the score. So let me share my screen so you guys can see it, right?
Yes.
All right, so first thing we're gonna do is theoretically we want this game to keep going on until we decide to cancel it. So we're going to do this line while true, and this will basically just make it so that everything under it will keep on going forever. So all of the game will just go on forever until we decide to cancel it. So after that, we're just going to put in this one command, window.update. And basically all this is going to do is that every time this loop will run, it'll update what's appearing on your screen with the new information that's going to be updated. Wait, let me actually, I'm gonna comment this out for a second and then run just so you guys can visualize what's on screen better. And then I will uncomment it. So yeah, I've done that. First thing we're gonna do is we're gonna actually have the ball move around. So the ball isn't currently moving, it's just in place if you actually like try to start a game. So we're going to use this command ball.setx. And inside we're going to use this other command ball.x coordinate to get the actual x coordinate and plus ball x direction. And basically all this is going to do is it's just going to set the ball to move on the x-axis. And we need to do the same thing for the y-axis. So we're going to do the same idea for the y-axis. Ball.set. Oh, wait, no, oops, that's not ball.set. Ball.y coordinate plus whatever ball y direction is. So yeah, up here, we set ball x direction and ball y direction to 0.3, but they weren't really doing anything until we just did this command right now. So now they're actually going to be moving. And now we are going to set the top and bottom borders of the Pong game. So border or vertical borders. And we're going to do this. So we're going to include this if statement here. And we're just going to check if the y coordinate is going to be greater than 290. So visually, what's happening here? Let me actually make this window a little bigger. So, okay. So visually, what's happening here is, let's say this line is 290, is y-axis, or y equals 290. That's the 290. Don't mind my bad handwriting. And it's just checking if the ball will be anywhere above it. So any value above 290, so above this line, is where this block of code will execute. So what's going to happen is we're going to want to set the ball to be in place for like a second, a microsecond. And then we're going to have the ball go in the opposite direction. So we're going to do ball y direction will equal whatever ball y direction was times -1. So in order to visualize this, let's say the ball's going up like this. It's going to stop for a second, and then it's going to go back down in the negative direction. And now we're going to do the same thing for the bottom boundary. So we're going to use another if statement. This time we're going to check if it's less than -290. So the reason why we're doing less than instead of greater than, let me annotate again. Let's say this line is -290. So less than will be anything below here, right? So these are values less than -290. If we used greater than, it would be going above, which is not what we want. So I will clear all these drawings for now. And then we are going to set the ball to go, actually, so on line 96, that should not be a negative. This should be. So this one should be a negative. And then you want to set the ball to go in the opposite direction. So same idea, just to annotate in case you didn't understand the first time. If the ball is going down like this, it'll stay in place for a second, and then it'll bounce in the opposite direction. So yeah, that's all we actually have to do for the top and bottom boundaries. But now we need to deal with the case where the ball will go through the left side or the right side. And if it does go through the left side or the right side, that means someone will have scored a point. So this time we're going to use another if statement, this time for actual goals. So let me comment that out. Goal setting. So we're going to check if the ball is going past 390. By the way, these numbers that I'm using here are like technically arbitrary, but since we set our window to be 800 by 600, these numbers just fit in best. So first thing we're going to do is if someone scores a goal, that means someone will have gained a point, or that means the ball will need to go back to the center. What I just said is related. So the ball is going to go to the center. So we're going to set it to go to 0-0, which is back to the center. Next thing we're going to do is we're going to have the ball go in the opposite direction of where it was going. So if you want to visualize what this line is doing, let me annotate. So let me clear what I've done so far. So let's say someone makes a goal here and it goes through. We want it to go towards the person who just won, because you don't want the person who just lost to keep getting pelted with the ball and then they keep missing and getting scored on. That wouldn't be very fair. So that's all this line is doing. Now we're also going to add 1 to player A's score. So I'm going to use this plus equals here. All this means is player A's score is going to be incremented by 1. And then that's going to be whatever player A's score was. So if it was 0, then plus equals will just make it 1 in the end. And after that, we're going to use this pen.clear command because we're going to need to update the scoreboard. If you remember up here, we used pen to keep the score and visually put it at the top and center. So pen.clear is going to wipe out all the information we had up there originally. And we're going to use pen.write to rewrite it. So here I'm going to say player A, and then we're going to use these curly braces. And then player B, we're going to use the same curly braces. And then we're going to use this command .format. Basically what .format is going to do is it's going to fill in these curly braces with whatever information we put into these parentheses after .format. So we're going to put player A score, comma, player B score. So player A score will be put in this first set of brackets, and then player B score will be put in the second set of brackets. And then we're going to need to include some other information. We're going to align it to the center. We basically want to keep all of like the layout the same as the scoreboard we had above, or we coded above when it was 0-0. And then we're going to change or keep the font the same. So it'll be Arial 24, and it'll be normal. So it won't be bold or italic or anything. So we've done the right side. Now we need to do the left side. If a goal is scored through the left side, that'll mean player B has gotten a goal. So we're going to use similar idea as before. If it's less than -390, so in case anyone needs to see this, let's say this line is -390. Don't mind my handwriting. Anything that's less than will be to the left. And it's basically the same idea as the code we just did. We're going to put the ball back in the center. We are going to have the ball go the opposite direction, so the loser doesn't have to deal with hitting it again. We are going to increase player B's score because they have just gotten a goal. And then we are going to clear the scoreboard and then update it with the new information again. There are too many things popping up. And we're going to align center. And then we're going to set the font. So we have just done the goal setting, but we haven't actually coded if the paddle hits the ball. So we're going to handle actual collisions with the paddle. With all. So we're going to use another if statement. If you've noticed, we're just using if statements to logically create all the mechanics. So we're going to use this command if ball, or if the x coordinate is greater than 340 and less than 350. So this first compound if statement, since there are two conditions here, this needs to be fulfilled and this needs to be fulfilled. So let's say the paddle is like at 340. So the paddle is right here, right? This left side will be 340. This left side of the paddle, since it has like a thickness of like 10. This left side will be 340. 340. And this right side here will be 350. So this if statement is just checking if the ball will be inside the bounds of the left and right side of this paddle. So if it's anywhere in here within the left side and the right side. But now we need to check if it's actually within the paddle, like vertically. So it needs to be within this top bound and this bottom bound. So I will clear my drawings again, and then we'll get back to coding. So we're going to need another compound conditional statement. So we're going to check the y coordinate now because we're checking the top bound and the left, or the top bound and the bottom bound. So we're going to check if it is less than the right paddle's y coordinate plus 40. And we need to check that it's greater than the right paddle's y coordinate minus 40. So this plus 40 and minus 40 are here because the y coordinate is just going to be one, like, it's just going to be 1 point, right? This plus 40 and minus 40 are going to make it so that it has some, like, there's some verticality in there. So it needs to be within this minus 40 and plus 40 of the coordinate, right? So it needs to be within here if the paddle looks like this. So let's clear again. So now that we set that, what we're going to do is we're going to use a similar idea to what we used when it hit the top boundary or the bottom boundary. We want it to bounce off, right? So we're going to set the ball to stop in place, so at 340. And then we're going to have the ball go in the opposite direction. So basically what's happening here is, so the ball actually goes inside here, then it'll bounce off. And now we're going to need to do the same thing for the left paddle. So we're going to check if the ball's x coordinate is going to be less than negative 340. Remember, it has to be the opposite sign of what's up here. It's going to be less than negative 340. And the ball is going to be greater than negative 350. So if we want to visualize this again, let's say the paddle looks like this. This right side is negative 340. And this left side is negative 350. So we just want to check if it's within negative 340 and negative 350, so somewhere in here. Now we're going to need the other condition again. So we're going to check if it's actually within the top bound of the paddle and the bottom bound of the paddle. So going to make sure that it is less than left paddle dot y coordinate plus 40. So this checks the top bound, and then for the bottom bound, going to make sure that the y coordinate is greater than the left paddle's y coordinate. I'm like minus 40. So same idea as before. If the paddle looked like this is negative, and let's say this is center. This is going negative 40 down, and going up, this is plus 40. And we're just checking if it's within the top boundary and the bottom boundary of the paddle. So next, we are just going to make sure the ball actually bounces off. So we're going to set it to negative 340. And then it will go in the opposite direction again. So the direction will multiply by itself times -1. And yeah, that's actually it for the code. So let's actually try to run it. Invalid syntax. So this line on line 37 should be it should be dot go to. Just say dot go to. And then I think it should run. It didn't run again. Line 116. Oh no. These are just small syntax errors. Oh, this should be an equals. Oopsies. Let's check if the other one, the other one does have it. Name y is not defined.
Just so everyone knows, it's totally common and normal to have like errors.
Line 73.
Especially since like we've been coding the past hour and we haven't ran it to check it. So
Right,
it's a good practice to like code
It should
everything
be
and run it in iterations, like do it constantly to make sure everything's working.
okay. So indentation really matters in Python. So these should both be indented to be inside this define.
Oh, it has. I didn't see
And
that.
now it should run. So here I'm pressing W and S. It's a little laggy because it's on Replit. So WS is controlling the left side, and the right side is controlled by up and down. I'm not hitting the ball.
Wait, is it like
the window is a little bit small, so it's hard. Okay, now it should be good. So now you can hit the ball around. And yeah, that's all you need to code the Pong game. Yeah, thanks for coming, everyone.
Yeah, if
One
anyone
more
has
than-
any questions, definitely let us know. Or yeah, why is the ball going at like the speed of an actual turtle?
I think it might be lagging a little bit.
Okay.
Also, you can change how fast it goes by increasing this number, this X direction, but I will stop recording now. Actually, I will stop sharing, then I'll stop recording.